Chapter 12 is on statistics. We're going to start by looking at the two different types of data. The first is when you have one variable data. This is called univariate. One variable data can be modeled using a histogram, which is a bar graph with the bars smushed together that's based off of a frequency table, a box plot, which we'll look at in a minute, or a dot plot. If you look over here to the right, the dot plot, it has a list of data, and then you use a dot to represent the frequency of each piece of data. And like I said, we'll come back to the box plot in a minute. So let's go back to then two variable data is called bivariate data. Two variable data is typically modeled using a scatter plot. And you also want to think about causal relationships. Does one variable cause the other to happen? For example, if you have the number of miles driven and the amount of pollution in the air, as the number of miles driven increases, the amount of pollution in the air will increase. That causes the other to happen. Measures of central tendency. A single number used to describe a set of data as a whole. There's three of the most common ones are mean, median, and mode. Mean is the average, which is when you add up all the data and then divide by the total number of data. The median is the middle value. So you would line up the data from least to greatest and then count to see which number is located in the middle. And then the mode is the number that appears the most number of times. Typically, mean and median are better measures of central tendency, and the mode is not actually all that helpful, but it's good to know about. Okay, I'm going to jump around a little bit on our page here, but on your TI Inspire calculators, those calculators can find the mean and median, and it can also find a lot of other helpful information. If you look at the box plot is based off of 5 different numbers. It has the minimum, and then it's separated into quartiles, which means quarters. So Q1, median, Q3, and the maximum being your highest, minimum being your lowest. And like I said, the calculator can find all of these values for you. So this box right here is your steps to finding it on the calculator. We're going to fill in some data here. So you would add a spreadsheet, you would add in all of your data, and then you would go back to a calculator and do menu statistics, and you'd be able to find the one variable to statistics. Again, this is called a 5-number summary. So if you ever had a question asking for a 5-number summary, you would need to find your minimum, Q1, median, Q3, and your maximum. On the calculator, when you see an X bar, which is this guy right here, that means the mean or the average. Also in that list is going to be the min X. That one's a little more intuitive, and that stands for your minimum. Q1X stands for your quartile 1. Median X stands for your median. Q3X is your quartile 3, and max X is your maximum. So if you need to create a box plot, you need to enter in all your data, find all of these numbers for your 5-number summary, and then let's look back at this graph for a quick second. You would set it up so that your data matches above a number line. If you were trying to read a box plot, they asked you what Q1 is, you would look right here and find out whatever number is down there. If you're looking for Q3, it's whatever number lines up there, maximum, your median, and your minimum, and so on and so forth. So you're going to use that number line to kind of find that data and find out information about the data. Okay, another general vocab thing when you're interpreting data, an outlier is the number that lies outside most of the other values in the data. So in class we talked about if I'm looking at test scores and the majority of the class scores around the 70% mark and one person scores in the 95 range, that would be an outlier. It's outside of the typical or the most of the data. Or it could be vice versa. If the majority of people scored an 85 and then one person scored a 40, that would be an outlier as well. So it can go higher or lower, either direction. Either way, if it's outside of what the norm is for the rest of the data, then it's called an outlier. You can see this chart here for skewed. If data is skewed, you can see the chart on the left here has it's skewed to the left, which means that the majority of the data is actually to the right side, which is over here. And then if you're skewed to the right, your majority of your data is going to be on the left side So that's just another way of looking at data as a whole and interpreting it. Okay, so far that's all about one variable data. Let's go and look at what happens when you have two variable data. So you're going to have your x and your y. We're going to look over here at your linear regression or line of best fit. Those terms can be used interchangeably, so make sure you know both of them because a question might ask using either of that vocab. So regression, or the line of best fit, is a line that best estimates the data on a scatter plot. So we're going to use these examples below here under correlation coefficient for a second. The linear regression, or the line of best fit, is this line that's drawn in the middle here of all this data. It's an estimate line used to estimate future or other values. The correlation coefficient is going to tell us how well that line of regression, or the line of best fit, matches the data. So essentially, is it a good estimate or is it not? The words strong and weak are used with the correlation coefficient. If it's a strong correlation, it's like these two yellow ones here. All of the data is very close to the line, which means it's a really good estimate. The ones below it have a weak correlation, and so all the data points are farther away from the line, so it actually isn't quite as good of an estimate. The actual data points aren't as close to the line itself. And then this last example here, there is no correlation because there's no way you could possibly make a line to go through all of that. When you're looking at your data, your correlation coefficient is either going to be between -1 and 1. If it's closest to -1 and 1, then it's going to be a strong correlation. You can see the numbers here, 0.93 and -0.9. The negative and the positive have to do with the slope. So it's just this one is a positive slope here, and this one is a negative slope on the right here. So that's where the negative positive comes from. But 0.93 and -0.9 are very close to +1 or -1. That means it's a strong correlation. It's a really good fit. Down here, when you have the 0.6 or the 0.5, that means it's kind of a moderate correlation. It's an okay fit, but it's not great. And then the terrible one, the no correlation, is the r equals 0. The coefficient would be 0, and that means it's a really bad correlation. There's no possible line that would fit there. And then the letter R is what represents the correlation coefficient. Your calculator will find both the linear regression and the line of best fit. Down here in the corner we have, I'll highlight it in green here. These are the steps for how to do that. You're going to enter in all of your data. You want to make sure you label it as X and Y next to the A and B column there. Then you're going to get that scatter plot. Follow that. You're going to add a document and add stats to get that. Once you get your scatter plot, you need to add the line of best fit or the linear regression. And then, and so your actual linear regression would be the y equals mx plus b, your actual equation of a line. And then if it says find the correlation coefficient, you're going to go from there back to a regular calculator, open up menu and statistics and some stat calculations, and that's where you'll be able to find the linear regression. When you enter that linear regression, it'll bring up a list that looks similar to your 5-number summary. It's a gray chart that pops up, and on that chart is the R, and you'd be able to find that R from there. So if a question ever asks you for that, you can always use your calculator. Even if you don't have memorized where to find it, use some intuition. It's either on analyzing or about statistics or under the menu button. So the more you use it, the more comfortable you'll get with it. But you can also just kind of try to think intuitively and figure out what would make sense, where would they put these buttons to make sense here? Where is it organized? Okay, the last piece to talk about is this two-way frequency table. You're given this frequency table that shows how often or how frequent something happens. When you're given this table, you want to always make sure you find the totals. In this case, these totals were given to us. That will not always happen. So if that green spot right there, the column and the row, are not there, I would recommend going through and filling those out, and you would just find that by adding these up. So for example, this 5 came from this 2 and this 3. So you'd add down in the columns and then add across as well. So first step is to find all the totals. And then second, you want to be really careful about how the question is worded. So for example, what % of females have a favorite color of red? So you're going to start by thinking about, okay, what % of females? That's what's going to tell you what's going to go on the bottom. So we're looking at the total number of females. So that's going to come from right here. So 13 is what's going to go on the bottom because something out of 13. So what percent of the females have a favorite color of red? And so our red is from here. That's 2. So your percent, you're going to start with 2 out of 13 as a fraction, and then you're going to put that into your calculator and figure out your percent, which comes out to 0.15, and so that's going to be around 15%. So 15% of the females have a favorite color of red. Now the next question, what percent of people who have a favorite color of red, so now that's what's going on the bottom. I'm going to use green for this one. So the total number of people that have the favorite color of red, which is 7, and then which percent of those are females. So now we're looking at, of those total 7, we're looking at the 2. So it's 2 out of 7. You're going to do that on your calculator, which comes out to 0.285, which rounds up to 0.29. So that would be 29%. So 29% of the people, of those 7 people who love the favorite color red, 2 of the 7, or 29% of them, are females. So you might get questions that ask you about them to read them, or you might be given information and use that to fill in. Either way, you're going to want to practice that and just be familiar with it. Although statistics is a small percent of the test, it's still good to be really familiar with these, and you want to do obviously the best you can. And so in particular, what I would recommend to make sure you know how to do is the linear regression and the correlation coefficient, and then knowing how to do that on the calculators is really important. Make sure you do some practice examples and the box plot. The box plot in particular, if you know how to read those, those can be easy points on the exam. So if you have any questions, please let me know.